This is question 10 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of estimated mean. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. This is the first part of a 4-part question. We've been given a table of data representing the profit made each day at a cricket club for a period of 100 days, and asked to complete the cumulative frequency table. Group data is data that has been organized into classes or intervals, rather than being listed as individual values. A cumulative frequency table is used to show the total number of values in groups up to and including the current interval. The table given to us has 2 columns and 6 rows. The first column represents the profit in pounds made by the cricket club. The groups are intervals of £50, beginning at 0 and increasing to £300. The cumulative frequency table is similar. The intervals increase by £50, but also include all of the values in the preceding rows. To complete the cumulative frequency column, we need to add the frequency of the current group to the sum of all the previous frequencies. The frequency of the first group is 10, so the corresponding entry in the cumulative frequency column is also 10. The frequency of the second group is 15, so the corresponding entry in the cumulative frequency column is 10 plus 15, which is 25. The third group has the frequency 25. With every new row, it's mathematically prudent to find the cumulative frequency by adding the value on the previous row to the new frequency. So, 25 plus 25 is 50. The fourth group has the frequency 30. So, 50 plus 30 is 80. The frequency of the fifth group is 5. So 80 plus 5 is 85. The frequency of the sixth and final group is 15. So 85 plus 15 is 100. We were told that the data covered a period of 100 days. So the fact that our final cumulative frequency is also 100 indicates that we haven't made any arithmetic errors. So the values of cumulative frequency entered into our table, and the answer to the first part of this question are 10, 25, 50, 80, 85, and 100. This is the second part of a 4-part question. We've been given a grid and asked to draw a cumulative frequency curve for the data in part 1 of the question. A cumulative frequency curve is a graph that represents the accumulated total frequency in a dataset. It typically takes the shape of an S, always starting in the bottom left corner of the grid and finishing in the top right. It helps us to estimate statistical measures such as median, upper quartile, lower quartile, and interquartile range. The grid we've been given has an x-axis representing profit in pounds from 0 to 300, and a y-axis representing cumulative frequency from 0 to 100. The first entry in our table is 10. But the first value we need to plot on our cumulative frequency graph has the coordinate 0, 0. That's because the lower boundary of the first class is 0. In other words, there are no values that we need to account for before the first group. To plot each value in the cumulative frequency column, we need a corresponding x value. For each interval, the x value is the upper boundary of that group. So, a cumulative frequency of 10 corresponds to the value 50 on our x-axis. So we need to plot a point with the coordinate 50, 10. The second value in the cumulative frequency column is 25, and the upper boundary of the corresponding group is 100. So we need to plot a point at the coordinate 100, 25. The remaining points that we need to plot have coordinates 150, 50, 200, 80, 250, 85, and finally 300, 100. Joining these points with a smooth curve, we get the characteristic S-shaped curve for a cumulative frequency. This is the third part of a 4-part question. We've been asked to use our graph to find an estimate of the number of days when profit was less than £125. To begin, we need to find 125 on the x-axis, which is the profit axis. Then we need to draw a vertical line from 125 up to our cumulative frequency curve. Before drawing a horizontal line across to the y-axis, the cumulative frequency axis. To finish, we need to identify the value at the point where the horizontal line meets the y-axis. And we can see that the value is approximately 37. For this question, an answer between 35 and 39 is considered acceptable. So, our estimate of the number of days when the profit was less than £125, and the answer to this part of the question is 37. This is the fourth and final part of a 4-part question. We've been asked to use our graph to find an estimate for the interquartile range. The interquartile range is a measure of dispersion and concentrates on the middle 50% of values. It's the difference between the third or upper quartile and first or lower quartile. The lower quartile is measured from the 25th percentile, which in this context is 25% of the total number of days, and the total number of days is 100. So we need to measure the lower quartile from the value 25 on the y-axis. So, from 25 on the y-axis, we need to draw a horizontal line to our cumulative frequency curve. Then, draw a vertical line down to the x-axis and identify the value where the line meets the x-axis. And we can see that the profit is £100. So the value of the lower quartile is £100. The upper quartile is measured from the 75th percentile, which, in this context, is 75% of the total number of days. So we need to measure the upper quartile from the value 75 on the y-axis. So from 75 on the y-axis, we need to draw a horizontal line to our cumulative frequency curve. Then, draw a vertical line down to the x-axis and identify the value where the line meets the x-axis. And we can see that the profit is £190. So the value of the upper quartile is £190. The interquartile range is the difference between the upper and lower quartiles. So the interquartile range is equal to 190 minus 100. And 190 minus 100 is 90. So the interquartile range is 90. For this question, an answer between 85 and 93 is considered acceptable. Answering this question successfully relies on our ability to construct cumulative frequency tables. Plotting cumulative frequency curves using upper class boundaries and using graphical interpolation to estimate specific data points and measures of dispersion like the interquartile range. Please follow us on Instagram, TikTok, and Threads for daily maths content.